Let's look at another topic from C++, that is the default arguments. A default argument is a value that uses automatically if caller of the function does not provide a value for the argument with default value. So default arguments, declaration and definitions. So let's suppose we have a function with name multiply and data type double, and when we declare it before the main function we write double multiply, and into the parameters we write int comma int is equal to 1. Here int is equal to 1 is our default argument. If we did not pass any value, then this function automatically use a value 1. And when we define our function, we write double multiply int x int y. Here int x value comes from the function call, and if int y values does not come from the function call, this function automatically takes the value int y and put y is equal to 1 as we declare a default value in the declaration of this function. So working with the default arguments, we have 4 different scenarios. In the first image, case 1, no argument passes, mean we create a function temp, and into arguments we write int is equal to 10, float is equal to 8.8. Here we use two parameters int and float, and we pass them the default arguments 10 and 8.8. So in the program, in the main function, when we call this function temp, and if we did not pass any argument to this function temp, and uh, when we define this function y temp int I and int float, then I takes the value of 10 from the function definition, and float f, where f got the value of 8.8 from the function definition. So when temp is called, both the default parameters are used by the function. In case 2, uh, we have the same program temp, and into the argument we write int is equal to 10 and float is equal to 8.8. In the main program, when we call this function temp, we pass only a single argument into it, and we write temp into 6. When control goes to the function, then this 6 value goes to int I, and as we did not pass any argument for float f, the float f automatically take the value 8.8 from the function definition. So when temp 6 is called, the first argument becomes 6, while the default value is used for the second parameter. Similarly, in this case 3, when we call function temp 6 comma minus 2.3, then when temp 6 comma minus 2.3 is called, both the default parameters are overridden, resulting as I takes the value 6 from the function call, and f now takes the value minus 2.2 from the function call. In case 4, where we write when function call temp into 3.4. So when temp 3.4 is called, the function behaves in an undesired way because the second argument cannot be passed without passing the first argument. Mean this value 3.4 goes to the variable I. But as we see that this is a floating point value. So and in our function definition we write int I, where I is an integer type variable, so it behaves in an undesired way. And similarly, without filling the first parameter, we did not put this value, or the compiler did not pass this 3.4 value to the float f. Example of default arguments. One, first of all, a function with default arguments. It can be called with 2 arguments or 3 arguments or 4 arguments. In this example, we define a function sum, and into the parameter we use parameter x, y, z and w. Last two parameters are used as default arguments, where int z is equal to 0 and w is equal to 0. So this function can be called with 2 arguments or 3 arguments or 4 arguments. And into the function we return x plus y plus z plus 4 to the main program. The main program, we first line is called with 2 arguments. We call this function sum and we pass it two values 10 comma 15. So when this function is called, 10 goes to the variable x and 15 goes to the variable y, while uh, while z and w takes the default values. And into the second line we call this function with 3 arguments. We write sum 10, 15 and 20. So here 10 goes to x, y store in y variable, and 25 store in z variable. Now z takes value 25 instead of z is equal to 0, and the remaining w variable use the default argument value, that is w is equal to 0. Similarly, when we call this function with 4 arguments and we pass 4 value to it, or we call this function with 4 values, we write sum into 10 comma 15 comma 25 comma 30. Then x takes the value 10, y takes the value 15, z takes value 25 and w takes value 30. Output of this program is look like as the call with 2 arguments. When we call this program with 2 arguments, it gives us sum is equal to 25. When we call this program with 3 arguments, it gives us sum is equal to 50. And when we call this program with 4 arguments, it gives us value sum is equal to 80. So here is some common mistakes when we're using default arguments. First one is as when we write function as void add int a, int b is equal to 3, int c, int d is equal to 3. What is wrong with this function definition is that the above function will not compile. We cannot miss a default argument in between two arguments. It means we cannot write int b is equal to 3, int c, int d is equal to 4. Here int c is not a default variable, so we did not write a single variable between two default arguments. In this case, c should also be assigned a default value. Second mistake is that when we define a function void add int a, int b is equal to 3, int c, int d. Similarly, the above function will not compile as well. We must provide default values for each arguments after b. Means when we write int a and then we write int b is equal to 3, here b is equal to 3 is the default argument. After declaring a default argument int b is equal to 3, we must have to declare c and d as a default arguments. So third common mistake is, if you want a single default argument, make sure the argument is the last one. So if we write this program as int a, int b, int c, int d is equal to 4, here d is equal to 4 is a default argument and this is the last one. So this function is declared with no error. So no matter how you use default argument, a function should always be written so that it serves only one purpose. If your function does more than one thing or the logic seems too complicated, you can use function overloading to separate the logic better. Uh, Here is a small quiz: which function correctly declare with default values? Here we have 5 examples of a function add. In first we write int add, then into the parameters we write int x, int y, int z is equal to 30. For the second point we write int add, then into the parameter we write int x, int y is equal to 20, int z is equal to 30. And third one we write int add, int x is equal to 10, int y is equal to 20, int z is equal to 30. In fourth one we write int add, in the parameters we write int x is equal to 10, int y, int z. And the last one we write int add, and then in the parameters we write int x is equal to 10, int y, int z is equal to 30. Now guess which one is valid and which one is not a valid declaration of default arguments. So here is the that first three are valid definitions of default arguments, and the last two are common mistakes and a violation of default arguments. In last lecture we wind up our discussion with default arguments. Now we have another type of arguments called placeholder arguments. When arguments in a function are declared without any identifier, they are called placeholder arguments. For example, the syntax is as void sum int comma int. In this declaration we clearly see that we only write int 2 times instead of writing int a or int b. Such arguments can also be used with default arguments. For example, we write void sum int comma int is equal to a. We did not give any variable to this data type int. So when we declare such arguments called placeholder arguments. Arguments in a function declared can be declared without identifiers. When these are used with default arguments, void if void f is our function name, Um, then int x int is equal to 0, float is equal to 1.1. In C++, you do not need identifiers in the function definition either. For example, void f int x int float flt. In the function body, x and flt can be referenced, but not the middle argument, which we declare with only its data type int, because it has no name. Function calls must still provide a value for the placeholder through f1 or f12, 3.0. This syntax allows you to put the argument in a placeholder without using it. The idea is that you might want to change the function definition to use the placeholder later without changing all the code where the function is called. Of course, you can accomplish the same thing by using a name argument. But if you define the argument for the function body without using it, most compilers will give you a warning message. Assuming you have made a logical error by intentionally leaving the argument name out, you suppress this warning. More important, if you start out using a function argument and later decide that you do not need it, you can effectively remove it without generating warnings and yet not disturb any client code that was calling the previous version of the function. So now we see scope of identifier or variables. Identifier is any name user creates in his or her program. For example, functions are also identifiers, and if we insert any type of labels, these labels are also called identifiers. Depending upon the storage class of a variable, it can be divided into four major types. Local variables, global variables, static local variable, register variable, and the last one, thread local storage. Every variable in C++ has two features, type and storage class. What is a type? Type specifies the type of data that can be stored in a variable. For example, int float char etc. And what is a storage class? A storage class controls two different properties of a variable. Its lifetime, that how long a variable can exist, and the scope of a variable, which means which part of the program can access it. What is a scope? A scope is a region of the program, and broadly speaking, there are three places where variables can be declared. Number one, inside a function or a block, which is called local variable. In the definition of function parameters, which is called formal parameters, outside of all functions, which are called global variables. So we have local variables, formal parameters, and global variables. Let's have an example. In this example, we start our program with int main, and after int main, we start the parentheses. This one is the first parenthesis, and after that we declare a variable called scp1, and its type is int. So now in our program we use this variable anytime. So after this variable, we start another parenthesis, another curly braces. In this curly braces, we declare another variable, which is int scp2. So scp2 visible here, it means that scp2 is only available after between the second uh, curly braces. After declaring int scp2, we start another curly braces, and in this curly braces we use int scp3, another variable. So in this start, when we start our third curly braces, now in this curly braces we also use our previous two variables, that one as scp1 and scp2, and also we use scp3 variable in this set of curly braces. After declaring scp3, we close the third curly braces. After closing the third curly braces, we did not able to use our variable int scp3, so but we still able to use the previous two variables, that are scp1 and scp2. So after closing the third curly braces, we close our second curly braces. When we close our second curly braces, now we are not able to use our variable scp3, sp2, scp2, but we are uh, able to use our first variable, which one is scp1. When we close our last parenthesis, we are not able to use any of these variables. So scoping rules tells you where a variable is valid, where it is created, and where it get destroyed. Destroyed mean it goes out of scope. We are not able to use it anymore. The scope of a variable extends from the point where it is defined to the first closing brace that matches the closest opening brace before the variable was defined. That is, a scope is defined by its nearest set of braces. Uh, in our previous example, shows us that when variables are visible and when they are unavailable. A variable can be used only when inside its scope. Scopes can be nested, indicated by matches pairs of braces inside other matched pair of braces. Nesting means that you can access a variable in a scope that encloses the scope you are in. In our previous example, the variable scp1 is available inside all of the other scopes, while scp3 is available only in the innermost scope. So